Hey everyone. Today we'll be looking at yet another session on discussing about two pointers. This is one of the most common algorithm out there that is used for array, strings, sometimes on trees, linked list, and graph as well. Before we get started, if you're enjoying our videos, please hit subscribe so you can get notification on new videos whenever we put them out there. And if you have feedback or would like to see videos on specific topics, please don't hesitate to leave a comment. With that being said, let's get started. So as mentioned at the beginning, two pointers algorithm is very helpful in arrays, strings, linked list, sometimes trees and graphs as well. The algorithm is pretty straightforward. It essentially, as the name implies, there are two pointers which are tracking two different elements in the arrays or any of the data structure. And then when based on the logic or the problem that you're trying to solve, you are performing an action when a condition is met on both the pointers. So let's take a look a little bit deeper. So for example, let's say we have an array, something like this. In this, we can have two pointers. Now, there are two different ways this can go about. So you can either have pointers over here and pointer number 2 over here, and they both could be moving in this direction. Or you could be having one pointer over here and one pointer over here, and they both are moving towards each other, right? To understand two pointers algorithm better, let's try to look at a problem. This problem is on Leetcode called move zeros. I'm just going to read out the problem. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. Note that you must do this in place without making copy of the array. We are going to, for the purpose of this discussion, we are going to ignore this note over here. The reason for that is it's important to understand different approaches that you can take to a problem and how do you get to a two pointers algorithm. The logical sequencing of steps is important over here. Although do note that this information will be something that you will have to ask the interviewer. The interviewer will not actually give you this information that, oh, I want you to do this in place. This is something that you should ask. And the question should not be like, hey, do you want me to do it in place or not? It should rather be, hey, do we have any space or time constraint to solve this problem? So let's take a look at the examples that are provided to us over here. The first one, which is 0, 1, 0, 3, 12. We can see that once the operation is done, which is moving zeros to the end, we can see that all the zeros are moved towards the end. However, the key thing to remember is that relative order is maintained. Again, this is something that you will have to ask the interviewer, because if the interviewer just gives you this example, it might not really be that clear if this was sorted or not, because 1, 3, and 12 are already sorted. So this is something that you might have to ask the interviewer. And a good way to ask would be to take a different example. So if I were the candidate, I would ask, hey, what would happen if the input would be 0, 3, 1, 0. 12. And of course, based on the problem, the response to this would be, the answer would be 3, 1, 12, 0, 0. So this behavior, this answer confirms to me that, hey, we cannot sort or we have to relatively maintain the order of elements in the array. The constraints which are provided below, which is 1 less than num's length and the range of the integers, also is something that you need to ask the interviewer. This is not going to be handed over to you just in a similar way like Leetcode does. You might have heard many people saying all the time that you have to ask questions to the interviewer, These are the questions that you're supposed to ask the interviewer. It's mostly related to what are the constraints to the problem. The constraints can come in terms of the machine or the time or the space complexity that you are running your code on, and the other can come in terms of input. So with that being said, let's try to explore a couple solutions over here. and we'll see why some solutions won't work based on the constraints, and why two-pointer would actually be better in this scenario. So let's take a look at solution number one that comes to my mind. So the first thing that comes to my mind is sorting. So what if we just sort the array, right? So let's look at the above example. We have 0, 1, 0, 3, 12. Now, if I were to sort this array in descending order, then I would get 12, 3, 1, 0, 0. So first of all, like, this clearly violates one of our requirements, which is that we need to maintain the order of the elements as they are presented to us. Moreover, the other problem is, let's say if we have a negative number in there. So let's say we have 0, -1, 0, 3, 12, and we have 12. The output would be 12, 3, 0, 0, -1. So clearly this solution is actually not going to work for us. If these constraints were not present, then the time complexity for this would be n log n, because that's the time that we take for sorting. And assuming the sort happens in place, we don't really have to use another array, so no extra space, and the space would be O of 1. So, but since this solution does not work, let's move on to the next solution. Let's look at another solution. Solution 2, copy to another array. Now, I know one of the requirements did mention that you cannot create another array up here, but we are going to skip that for now, just so that we can actually get to the two pointers approach. So in this case, what I would do is I would create a new array, and I would essentially have a pointer over here, and I would have a pointer on my input array. The logic, the way this would work is I would copy from my original array to my new array if I encounter anything but 0. And then for the remaining elements, for whatever is empty in my resulting array, I will just fill out 0. So let's take a look at this. So let's say we have a tracking element, which is index. So let's assume that we have iterator id x, and we have another tracker, which is id x2. So the green is tracking the new array and the blue is tracking the actual array. So when idx equals 0, our current element in this case is 0. So we are going to skip that. Our idx2 will still remain at 0. The next element, which in this case would be index number 1, the value index is 1, which is not equal to 0. So we would change that in our new array, and we would move idx2 to index number 1. The next index, which is index number 2 in our given array, has a value of 0. So we are going to skip this one, and our idx2 remains exactly where it is, which would be index number 1. On the next iteration, our idx1 would be 3, in which case the value would again be 3, and idx, which is not equal to 0, so we would copy 3 into the new array, and we would increment idx2 again by 1. Now, on the final iteration, when our idx1 will be on index number 4, the value is 12, which is again not equal to 0. So we would move our so we would copy that to the new array, and we would move idx by 3. So towards the end, our idx2 is on index number 3, and then we would essentially have a for loop from wherever idx2 is ended and just fill everything with 0. So the pseudocode would look something like idx2 equals 0. So let's take a look at time and space complexity for this. So the time complexity for this would be O of n being number of elements in the array, because we have this main for loop out here, which essentially goes through the entire array. And then our space complexity is also O of n because we are allocating a new array as a resulting array. So this is our solution 2. Now let's take a look at solution 3, which is a slight modification of exactly this solution, but without using a resulting array. So let's start with the final solution, which is 2 pointers. This solution is actually derived or inspired from our previous solution, in which we essentially had 2 arrays and 1 pointer on each of the arrays. So we did have 2 pointers, but they were tracking 2 different arrays. If you remember, the concept or the approach in that was the pointer on the new array was tracking elements which were non-zero versus the first iterator was just tracking all the elements. So we'll use the same concept, but we will use 2 different pointers on the same array so that we don't have to use an extra space. So we have IDX1 and we have IDX2, and we have the iteration number, which is indicated in yellow. So at the init, both of them are essentially at 0. So on the first iteration, the check that we have is the current element that IDX1 is pointing to, is it 0 or not? If it is 0, we do nothing. If it is non-zero, then we move it to where IDX2 is pointing. So in the first iteration, we have the value at IDX1 is 0. So we do absolutely nothing here. So at the end of the iteration, IDX1 moves to the next index. But IDX2 remains exactly where it is. Now we have the value at IDX1 is equal to 1. So in this case, it is a non-zero element. So what we'll do is we'll take 1 and we will move it to where IDX2 is pointing. So we moved number 1 to position where IDX2 was pointing, and we'll move IDX2 by 1. IDX1 will move to the next element, which is index number 2. One question I have for everyone who's watching this is, what do we do with this? Do we have to replace it, or do we keep it as is? The answer is that we keep as is, because we can assume that everything that is after IDX2, actually from where IDX2 is and everything after that is yet to be evaluated. And if it is a non-zero element, it has been moved to a position before IDX2. So we don't need to do anything about it. So let's look at the next iteration, which is iteration number 3. In this case, again, 3 is a non-zero element. So we will move 3 to where IDX2 is pointing, and we will move IDX2 by 1, and IDX1 will again move by 1. Okay, so now IDX2 is pointing to the new location. IDX1, the value at IDX1 is 0. So in this case, again, we don't do anything. IDX2 stays where it is, and IDX1 moves by 1. Now the final element is again a non-zero element. So what we do is we move the non-zero element to number where IDX2 is pointing, and we move IDX2 by 1. So there we go. Now we have to, again, same as the previous one, we essentially go where IDX2 is pointing and fill out everything with 0. So here is what our pseudocode would essentially look like. IDX2 equals 0. That's what our pseudocode would look like. Now, what would be the time complexity and space complexity for this? The time complexity for this would be O of n, because again, we are going through the entire array in our for loop. And our space complexity in this case would be O of 1, because we are not using any extra array. So I hope this solution made sense. Now, next we'll look 2 things. One is, how do we come up with such an algorithm when we are under pressure in the interview? And second, what is a blueprint for this kind of question? So we looked at 3 different solutions. Now let's look at solution number 2. So let's say we come up with this solution and the interviewer tells us, hey, can you actually make it more performant. Most of the time, when you have linear complexity, going to log n is actually very hard unless the array is sorted and you are just doing a normal search. So you have to assume that this is going to be a linear operation no matter what. So the only thing that you can actually optimize on is your space complexity. So how do we come up with such an algorithm in a short period of time? So of course, practice is the key to it. But one of the intuitions or one of the cues that I use is whenever I see that an array, the input array is same in size and content than my result array, then it kind of gives me a sign that I could potentially do some sort of swapping to figure out if I can not use that extra array. Now again, this may or may not be possible for every problem, but it definitely is worth considering. So what I would do in an actual interview is I would look through this and I'll be like, okay, it seems that I am just moving the elements around, but I am not really doing any kind of, like, my array size is not increasing or decreasing, or the elements are not completely changing. So in that case, two pointer would be the first thing that I would try. The second thing I would try would be sliding window. But what I would do with two pointers is I would basically just exactly try to replicate this process with two pointers on the same array and see how I can actually move them. Once you are actually able to make sense or problem solve it, then it's a matter of coding it up, which is, again, that part is the one of the most trickiest part, and that absolutely comes with practice. Determining what your for loop is going to look like and determining what this if condition will be are the two key challenges. So once you figure those out, I think you will be able to solve this problem much faster. Okay, so let's try to live code this solution. If you remember, the pseudocode for this was... So with that in mind, let's... Now we don't have to check for 0 because the constraint mentions that it'll at least be 1. So I will just check for 1. We can't return anything because this is a void function, and that precisely is because they do not want us to make a copy of the array. So anyway, this also could be another way to check if you are allowed to make a copy or not. Just confirm the function definition with your interviewer. But for this, you would need to know that arrays can be modified by reference, which is true in Java and actually in most of the languages. Anyway, moving on to the problem. So we have int idx2, which will be 0. Okay, so we have our for loop defined. Now the condition here would be keeps track of non-zero position. So we'll have if Okay, so we have passed it both the cases. Now let's try to run, let's try to submit this. There we go. So we have submitted the solution and it works. All right. So thank you once again for joining. And if you have any suggestions or if you'd like to cover some different set of problems, please leave me a comment. Thanks a lot.